Hey peeps, it's Jedd here from Disrupt Tutoring, and as always, it's such a pleasure to join you. Today we're going to deal with a cubic function and straight line graph question that we've taken from the IEB's 2019 supplementary exam. With that in mind, let's dive straight in. They've said to us the graphs of a cubic function f and a straight line g are sketched below. They've also said to us the equation of the curve is given as f of x and g of x. So f of x is our cubic function, g of x is our straight line. F and G intersect at the stationary point, so we can see that over there. Then they've also said to us f dash of x equals f dash of minus x for all real values of x, and f dash of minus 1 equals g double dash of 2. Right, so the very first question they've said to us is determine the values of b and c, and they've said show all working. Right, so I'm going to start off with the very important information they've given us over there, which is f dash of x is equal to f dash of minus x, and I'm going to find the derivative of f of x now, so that's going to be minus 3x squared plus 2bx plus c, and then the d falls away because it's a constant. I've applied my exponent laws there, equals, now it's the exact same thing, but everywhere I see an x I need to subs in a negative x, so that's going to give me minus 3. It's going to be minus x squared plus 2b minus x plus c. Right, I'm going to use a step just to get rid of those brackets to neaten things up for myself. So it's going to be minus 3x squared plus 2bx plus c equals minus 3. That minus x squared becomes a positive x squared. So it gives us x squared minus 2bx plus c. Now I can cancel some stuff out. The c's are going to cancel out, and the minus 3x squareds are going to cancel out. So I'm left with 2bx equals minus 2bx. I'm going to get all my x's to one side. So that's going to give me 4bx equals 0. And when I divide both sides by 4x, it's going to give me b is equal to 0. And that's the first part of the question, specifically to calculate b which equals 0. They've also asked us to calculate c. And I'm going to use this other very important thing they've told us. So they've said to us f dash of minus 1 equals g double dash of 2. So I'm going to first calculate g double dash of 2. Okay, so let's first calculate g dash x. Okay, and that's going to give us, so we're going to use our exponent law again. That's going to give us 2. All right, so it's what we expect, right? Because this is a straight line graph, and we know the gradient everywhere on that straight line graph is going to be the same. When we look for g double dash, okay, is going to give us 0. Why is that? Because the 2 acts as a constant and it falls away, which means we're left with a 0. So that means, therefore, that g double dash of 2 is simply equal to 0. Right, so they've said to us f dash of minus 1, so f dash minus 1 equals g double dash of 2. Right, so now we need to calculate that f dash of minus 1. So we're going to use the derivative as we found it over here, right? And that's going to give us minus 3 times minus 1 squared plus 2b times minus 1 plus c equals, then the g double dash 2 is going to equal 0. Right, we're going to neaten up those brackets now. What I'm going to do is just give myself a little bit of space. So I'm going to clear out this little part over here. I'm going to leave b equals 0. Remember, you guys are going to be recording all of this in the test. I'm just giving myself some space. Right, so I'm going to square out that bracket over there, and that's going to give me minus 3 times 1, which would give me minus 3. And then that's going to give me minus 2b plus c equals 0. We know that b is equal to 0, so this term over here will become 0. So we'll be left with minus 3 plus c equals 0. When we carry that negative 3 across, it becomes a positive, and therefore we know that b equals 0 and c equals 3. And that's it from me. Very nice job. A very special thank you to our sponsor for making this video possible. Be sure to read all about them in the description below. Also, head over to our website for more of these epic tutorial videos. If you can't find the answer to your question, send us the question and we'll respond with a personalized video just for you. Until the next time, stay epic.